Today I want to talk about capital recovery calculations. The idea behind capital recovery is that if you invest in an asset, you're making an investment and you want to get something out of it. And you often get, what you get out of it is savings. And we have the capital recovery factor that allows us to calculate what savings we'd need to justify a particular first cost. Although we have that capital recovery factor, it, by its nature, doesn't include what is often a very important component of practical capital recovery calculations, which is the salvage value. Usually we keep an asset for a certain number of years, a certain period of time, and then we dispose of it. And there's usually some income associated with that disposal. For example, we buy a car, we pay some money for it, we keep it for a few years, and we don't usually just leave it in the backyard to rot when we're done with it. We sell it, even if it's to a junkyard, and get some money back for it. So in practical capital recovery calculations, we almost always have this salvage value or surplus value that we have to take into account, because that's money coming in that affects the amount of savings we need to justify the original investment. Now, because of this fact, in practice, there's been developed a formula that includes both the present worth and the salvaged worth into the calculation to enable us to determine what savings are necessary. And what I want to do in today's talk is to derive that formula that's used for capital recovery calculations. Now, define a few terms here. Let's let S equal salvage value. After n years or periods. P be a present cost or present worth. And A, the annuity that's involved here, would be the savings that you need to achieve, or what we can call the annual cost of capital recovery. Right? So if we have buying an asset that has a present cost and a salvage value, and we want to find the savings we need, or the annual cost of capital recovery, what we'd have is this present worth converted to an annuity using the capital recovery factor. At some interest rate. And then minus, because we're looking at costs, and the salvage value is a benefit. That salvage value taken into an annuity. Now that's from the future, because the asset's going to be sold or scrapped n years from now. So what we're using is the sinking fund factor for that future benefit at the same interest rate over the same number of periods. So this really is the formula we want to find that annual cost of capital recovery. Now you'll notice in your notes that we actually have a mathematical relationship between the capital recovery factor and the sinking fund factor. The mathematical relationship is that the sinking fund factor, so I'll write here noting that this relationship occurs, that sinking fund factor plus the interest rate is equal to the capital recovery factor. What we can do is to simplify this equation by substituting in here. So what we end up with is we can put everything in terms of the capital recovery factor and get rid of the sinking fund factor completely. And we get the following. So we've got the present cost multiplied by the capital recovery factor minus that salvage value multiplied by the capital recovery factor, and also minus I. So I can take that present worth and the salvage value and bring them together as P minus S times that capital recovery factor. And then the two minus signs cancel each other. You get a plus sign and SI. And what we end up with here is a formula that is marginally easier to calculate because we only need the one transformation factor, the capital recovery factor. And what we do is we subtract the salvage value from the first cost, multiply that capital recovery factor, and take that salvage value, multiply the interest rate, and add it on. So it's marginally easier to calculate. Now, in these days of hand computers and calculators and stuff, that ability to save a little bit in the calculation isn't nearly as important as the second reason why I want to expose this formula to you, is that in real engineering practice, a lot of things are done by rote, by sort of procedures that are laid down. You open a book for a procedure, you see the procedure, you follow it, then you make the decision. Just because a lot of decisions are made on such a regular basis, it's just not necessary to work out from basic principles how to do things each time. And what you'll see very often in these kinds of rules of procedures is this capital recovery calculation formula. It's a sort of a classic. And so it's important to be exposed to where it comes from. So when you might see it in engineering practice, you don't need to scratch your head and say, well, that's not the way I learned it. It actually is the way you learned it. It's just that things have been combined together in what in the past was a more useful way and is now a traditional way of doing it. But you might find that if you're aware of this formula, that you want to use it doing your own calculations because it does offer that little bit of extra convenience in calculating. So let's look at an example using this formula. Waterloo Snacks wants to buy a new potato chip cooker. We have a first cost of $1,400,000. After 12 years, it has a scrap value of $250,000. At 10% interest, how much must the cooker save annually to justify this investment? So this is a classic problem of capital recovery. We have the first cost, we have the salvage value, we have an interest rate, we have a number of years involved, and we want to know how much savings we have to justify buying it. So we're looking for that annual cost that would be equivalent to that set of cash flows. We know from our capital recovery calculation formula that we take that first cost of $101,400,000, subtract off a salvage value, multiply that by the capital recovery factor of 10% for 12 years, and then add in that salvage value times the interest rate of 0.1. And so it's very straightforward from there. We just substitute in the value for that capital recovery factor, and we end up with $193,774. And so the answer would be that the cooker would have to save $193,000 per year, taking into account both the first cost now and that eventual salvage value. Now this salvage value was small, and so the difference between this calculation and if we ignore the salvage value probably isn't too much. But in other circumstances, it could be extremely important to include that salvage value. So the capital recovery calculation formula isn't particularly different from what we've done before. It incorporates the same principles. You're dealing with a set of cash flows converting to an annuity. What it does do, it provides a slightly more convenient calculation, and more importantly, it's what in practice is very often used. Thank you.